Bismillah Rahman Rahim. Well, dear listener, the topic is benzene and its structure. In first part, we will discuss the history, and in second part, we will discuss the structure of the benzene in detail. First, the history. The three major scientists who made contribution for the isolation of benzene. Number one, Michael Faraday, who in 1825 isolated it from the oily film that was being deposited by illuminating gas, and he called it bicarbonate of hydrogen. The second scientist, uh, Ilhard Mesherlich, who in 1833 produced benzene via distillation of benzoic acid and lime, and he called it as benzene. The third, the most famous, A.W. von Hoffman, isolated benzene from the coal tar in 1845. Coal tar is the black liquid mixture obtained from the destructive distillation of the coal. Chemical formula. The empirical formula of benzene was calculated as CH, and then after the molecular formula was found to be C6H6. That shows it is highly unsaturated hydrocarbon. The structure of the benzene is the next destination. Structure of the benzene remained a mystery for 40 years after being familiar to chemical formula, and it's such a long time in the field of research. Then a dream solved the problem. The Kekule, the famous Kekule who was sleeping, saw a dream. He saw dancing atoms assembled to form snake, and snake have its tail in its mouth, forming a ring. So that idea enlightened in his mind to design the regular ring structure of the benzene. X-ray analysis of the benzene that confirm the Kekule structure. The carbon-carbon bond length was calculated as 139 picometer, carbon-hydrogen bond 109 picometer, and the bond angle is 120. Atomic orbital treatment further explains the structure of the benzene. A regular planar cyclohexagonal ring is explained by sp2 hybridization. 2s, 2px and 2py orbital intermix to form 3sp2 hybrid orbital, while 2pz remain unmixed. So on one carbon we have 3sp2 hybrid orbitals and one unhybridized orbital. 6 carbons in benzene ring we have. So the structure, yes, 2 sp2 hybrid orbitals overlap with 2 sp2 hybrid orbital of other 2 carbons, and third sp2 hybrid orbital of the carbon overlap with 1 s orbital of hydrogen, forming a ring planar structure. Hexagonal ring, all the bonds are in single plane, so this is the planar structure. Next destination is sheath of the delocalized electron density. 6 carbons we have, so 6 unhybridized p orbital overlap to form continuous sheath of electron density, forming overlapping above and below the internuclear axis. So finally we have the sandwich structure like this of the benzene. Above and below we have continuous sheath of electron density, and in between we have the benzene ring. So stay at home, stay safe, ask if any in comment. Thank you.